Still on quadratic equations, we are going to continue with the next method of solving quadratic equations. We are going to look at how we can make a given quadratic expression. I know we've been talking about equation, but right now we are going to make an expression. A given quadratic expression, a perfect square, so that it can be factorizable. Recall that we said that all quadratic equations come in this form: ax squared plus bx plus c is equal to 0. Now this one is an equation, but the question I'm going to be giving, a proof I'm going to give, that one is not a perfect square. So what do we do to make it a perfect square? Because we know that there are some equations that comes and cannot be factorized. Okay, so let's take for example, given this, we have what must be added. We want to make a proof to show what must be added without us thinking it twice, to make a quadratic expression or equation factorizable. Like this one is an expression because there's no equal to sign. To make the expression a perfect square, what must be added to x squared plus 6x to make the expression a perfect square? Now let's prove, let's see what must be added. Suppose x squared plus 6x. Remember, quadratic equation comes in this form, so let's add a constant. Let's call the constant k. Is a perfect square. Meaning if I add k to this, it has made it a perfect square. And let's equate it. Let's equate it to a perfect square that we know, x plus a. Let's call this x plus a perfect square. So now let's bring everything down here to equate it and turn it into a perfect square. And see, x squared plus 6x plus k is equal to the perfect square, x plus a all squared. Now let's open the bracket so that it will look the same, because there's no bracket here. Let's also make the same thing here. So we have x squared plus 6x plus k is equal to, now for you to open the bracket, remember 2 square means 2 times 2. X plus a means x plus a times x plus a. It means everything in this bracket multiply by everything in this bracket. So let's use the first letter to multiply everything here. So we start with x times x, we have x squared. Then x times a, we have plus ax. We're done with using x, we make use of a. A times x, we have ax. A times a, we have a squared. So we have x squared, ax plus ax. This is 1ax plus 1ax. That's 2ax plus a squared. So this is what the whole of this, we move it here because we have already open the bracket. So we have x squared plus 2ax plus a squared. This one is the constant, this one is the coefficient of x, and then we have x squared. Okay, if you look at x squared and x squared, they are common, so we let them go. So let's equate the coefficient of x with by themselves. 6x is equal to 2ax. We want to make a the subject. To make a the subject, to make 2x disappear. So whatever I do to here, you do to the same thing here. X cancel x, 2 cancel 2. X cancel x, 6 divided by 2 is 3. So it then means that a is equal to 3. Now that we have gotten a, which is our constant k, we also equate it with the constant here too, a squared. Our a already that we find out is 3, so it means k is equal to 3 squared. So that means k is equal to 9. It then means that since we've found out k, all our proof have made us understand that the number we need to add to this expression to make it a perfect square is 9. So what we now have now is no longer x squared plus 6x plus k. Now our k becomes 9. So how do we know how we found 9? How do we know how we found 9? From here, we said 6 divided by 2. 6 divided by 2 is the same thing as 6 times half. Okay, that's half of the coefficient of x. Half of the coefficient of x gives us what? 3. How do we get 9? The square of the 3. So it then means for us to make an expression or an equation a perfect square is that you add half the square of the coefficient of s. Okay, so now we know that what we need to do is that we need to add half the square of the coefficient of x. Now let's take for example, without proving, the proof have already told us what we need to do to make an expression a perfect square. We're giving an example. What must be added to b squared plus 10b to make this expression a perfect square? Recall from our proof, we said half the square of the coefficient. Here the variable is b, so it's no longer the coefficient of b must be added. So half of 10 is equal to what? 5. Half the square. We have gotten this half. Then the square of 5 is 25. That means we'll add b squared plus 10b plus 25 is what must be added. 25 must be added to b squared plus 10b to make it a perfect square. What must be added? Recall what we said. We say half the square of the coefficient of d. So half of minus 5 is what? Minus 5 over 2. You square everything. Once you square negative number, it becomes positive. So we have 25. The square of 2 is 4. So what must be added to d square minus 5d is 25 over 4. That gives us answer. In the next class, we'll see more examples on how to use completing the square method in solving quadratic equations that are not factorizable.